about integers and give some examples on how to use them, because integers are really a useful way of writing code, or a useful tool when writing code. It allows you to have some shortcuts. It allows the program to gather information and put that information together. So it does give us some shortcuts to writing code and some helpful ways of doing this. Now, an integer is a variable. And what's a variable? Variables are information that is stored early. Let me say it again. Variables are information that is stored early in the program for later use. They can save a lot of writing. And that's what I'm saying. You start using variables, and there's more types that I'll talk about here in a second. But we're going to focus on integers in this one. You start using integers, then what it does is it saves you some type, and it allows you to make one statement that you could use at various times in the program. So it just makes things easier for you. There are different types of variables. There is the integer, and when we use an integer, we are referring to a positive or negative whole number, including 0, right? So there's some examples of values there. You're welcome to pause this and look at all the examples and everything else. But that's what an integer is. A floating point decimal, which in code would be a float, we're not going to use that in this section, but anytime we need decimals, we're allowed to use a float. We don't want to use a float, so some people ask, well, why don't I just use a float all the time? Which you could, right? You could do it. If I needed something that was 33, that had a value of 33, I could call it an integer. I could also say it's 33.0 and call it a float. The difference is a float uses more memory. So when I'm trying to make a program more straightforward, more elegant, if you will, then I tend to want to stick to things that I know are going to be whole numbers. I tend to want to use an integer because the computer just doesn't need to resort so much energy in storing those values. The other ones are Boolean, character, and string. And I don't think we're going to talk about those at all this year, but these are other ways, those are other variables that can be used. Where a Boolean one is actually one that gets used quite a bit. A character, again, is just one symbol. And then a string allows you to put a sentence or a statement in there. So the one we're going to focus on is an integer. So an integer can be a positive or a negative number, including 0. And the range is pretty big, right? For the memory that we use, which is a small amount of memory compared to some of the other variables, right? We can go all the way from, let's see, these are hundreds, thousands, millions, billion, -2, 140 billion, 147 million, 483,648, all the way up to the same thing, positive, right? So we got a pretty big range of values that we could fit for an integer. Now, I'll give some examples, but let's go through some of the rules for these integers. So, first of all, when we have an integer, we are going to put a name to it, right? We are going to say that, let me just show a quick example, and then we'll talk about these rules. So if I had an integer, I would say at some point, okay, I have an integer, and I'm calling that integer speed. So now the word speed can be in my program, and I'm telling the computer, hey, whenever you see this word speed, it's going to be an integer, which means it's always going to be a whole number. It's always going to be in the range that we just said, so on and so forth, right? So these names have rules for them. First of all, when I name it, I can't have any spaces in it. It can't be multiple words with spaces in between them. There simply can't be any spaces in the name. It can't have any symbols in it, so it can't have an exclamation point or the pound sign or any of those things. It can have a number in it, but it can't start with the number. So it certainly can be called like speed 1, and then I can have a second one integer, that's speed 2. I can do that as long as it doesn't start with the number. And the last thing is you can't use a name that the computer's already using, right? So it says a variable cannot be the same as an existing reserved word, right? So we can't take a name that already is used in the program and then give it an integer name, because then the computer will get confused, right? So if it was like timer, well, you can't use timer because timer is something that the code already used. So if you name it as an integer, it's going to be confused because like, hey, wait a second, we already know what a timer is. You can't change the words we know. So you just got to stay away from words that already exist in the code. For example, These are proper terms. Line counter, just fine. Line counter with a space in between, can't use it. Threshold would be just fine. Threshold with an exclamation point, there's a symbol in it, can't use it. Distance 3, just fine. 3 distance, no. Right? I can use time counter because that's not a word that it uses, but time 1 or T1, these are all off limits because these are things that already get used in the code. So there are some examples that match up with these statements of spaces, symbols, numbers, reserved words. So again, at any time, you could always pause this and see what I'm talking about, or think about it for a second before you move on. So those are the rules for naming integers. Now, for assigning integers, we have some rules for that. When we assign an integer, we are saying that it's equal to something, not not equal sign, because again, this is a question, right? So it's saying, is it equal to something? No, we want to say that the integer that I've made up in my example that I'll go back to in a second, speed is equal to something. So we always want to set it equal to something. At some point we need to. We might ask a question with it later, if it's based on an equation, if it's based on other sensor values, if it's based on inputs from other places, we can certainly frame a question and say, is that integer equal to this now? But at some point when we start it, when we first set up the integer, we've got to set it equal to something. The computer has to know how they're going to use this integer. Once we do that, right, at the start of a program, we could set a value, and then that value could be changing because it could be based on other information. It could be based on an equation. It could be based on a lot of different things. So what it'll do is every time you kind of ask it to redefine itself or recalculate what it is, then from that point on, it'll always use the most recent value. And it'll overwrite any old values. It can be used in a calculation, right? And it'll do the math and then store the value and use that new value that it calculated moving forward. And if I set it equal to something, if I'm using it in a statement, like a while statement or an if-then statement, I can put it on either side of the equal sign or the less than or greater than, whatever I'm doing, right? If I'm asking it to be part of a situation, it doesn't matter which side I put it on, right? So we'll see some examples, I hope, but I can really just put it anywhere I need to. It's not really, the code is not too fussy where I use integers. So that's when I say it can appear on both the left and right-hand sides of an assignment statement, right? It just pops up anywhere. It simply means that its current value will be used in calculating the new value. Assignments can be done in the same line. So this one's saying that I could assign it as an integer and I could set it equal to something like 0 as soon as I assign it. So I could say, hey, I'm going to use this integer speed, and speed is equal to 75, right? So if I go back to this example, sorry, where's my example? There it is. This does it in 2 steps. This says, okay, there's this integer of speed, and speed is equal to 75. So it's done it in 2 parts. But I could put all this together and just say the integer speed equal to 75. So I can do it in 1 step if I want to. Whichever way works for you is fine with me. But that's what it's saying. It's given an example here, right? Integer x equals 0. This is a perfectly fine statement to put it in. You're saying you're declaring what your integer is, and you're saying that, hey, we're starting out at 0 with this. Once I define it, or once I declare an integer, I say, hey, I'm going to be using this word speed, and it's going to be an integer, and I'm going to start it at 75. Once you say that stuff at the beginning, then now I can type that word in. When it says type the integer, I could type that word in wherever I want to use that value of 75. So I can put it anywhere I want. Basically, replace that number value. And if it's based on some calculations, then it'll do the calculation, and then the very next line it'll use a new number. If the third line asks it to recalculate it again, well then after that it'll use the new number, right? But it always, when you tell it to do something with that integer, it will do whatever it needs to do, and then it'll go forward with the new number until you tell it to do something else. So here's some statements that we can do that match up with our rules for assigning integers. I can just make one like motor power, and make it equal to a value, right? Why would I want to do this? Well, we'll see some reasons in a little bit. But I can do that. I can just say, hey, every time I use the word motor power, that means 75. I could set it equal to a sensor value. I could say, hey, this integer sonar variable is equal to whatever the sonar sensor is reading, which is good because once I set this variable, I can ask questions about this and I can use sonar variable. Um, I can use an integer called sum, which is going to add things together. I can do other math, right? So I'm not limited to adding things and finding the average of things. I can put in any equation I want, but the integer is sum, which would be the sum of other variables. It could be average, which is the average of other variables. So I can make the average of like 3 sonar readings or something like that, right? I can do various things with that. I could also use an integer to keep increasing. If I go through a loop and I want it to run through this loop and do whatever's in the loop 10 times, I could say the integer is count and count equals 1 plus 1, right? And then that means the first time it goes through it, the count is, well, I'd have to declare initially, but let's say I declared somewhere in the code that the count was 0. And then I put this statement in the loop. Well, when it goes through the loop the next time, the count is 1. The next time it's 2. The next time it's 3, because it's going to take whatever the value is and add 1 to it. So it's going to allow us to keep counting and going up, or going down, or making any changes I want. And then I could also do what I said before. I could just establish one. I could say, okay, I have an integer and it's 0, and I could establish initially I want it to be equal to 0. This tends to be one of the most common statements. The very top and the very bottom ones tend to be the most common statements that we see. I'm not saying the other ones aren't useful, but they're useful in specific situations. But it's very common for us to set an integer and make it equal to something and never change that, right? Or we'll see an example of that where I just set a value so I could use that value. Or it's initially I set an integer, say, okay, for starters it can equal to 0. And then later on I'm going to make an equation about it. So let's look at some examples of those things. So here's the one that I referred to a couple times. I have this integer, and I've called this integer speed. So I've used the word speed as my integer. So I said, hey, I'm making this integer. I'm going to use it. It's speed. So that's telling the computer, hey, look for this word speed. It's going to have to be whole numbers all the time. It's going to be all the way to the 2 billion to negative 2 billion, right? That big number that I said, including 0, could be any of those values. And again, by making it an integer, it doesn't use that much space. The computer doesn't have to reserve that much space to memorize or to use this value. And then the very next line, I say, okay, speed is 75. Now, this is a really short program, but let's say that we needed the robot to drive around a whole bunch of places, right? So basically, this is going to drive forward, right? The motors that are in port 3 and port 2, how much power are they going to use? Well, they're going to use speed. What's speed? 75. So basically, these drive forward at a power of 75. We can essentially just take these two words out and insert 75 in their place, right? And I'm going to do that for 2 seconds. So it's very basic code. And in this case, why would I want it? Well, this isn't a great example of why I'd want to use it. It's just an example of how to use it. Because if I was saving myself, this was the whole code, make a robot that drives forward for 2 seconds. Well, it'd be much easier if I got rid of this, and I got rid of this, and I just put 75s in those spots, right? Then I would save me 2 other lines of code. But along with that, what if I had many more steps to this? Maybe it was driving through the labyrinth or driving through the maze that we made in class. Maybe it was doing one of those things. So I kept, it did this for 2 seconds, and then it turned left, and then it went straight, and then it went back, and it kept doing all these different things. Well, now, every time it drove straight or it turned or it did things, right, I could keep using these commands speed, and I could keep putting them in. And let's say that it wasn't working out because all my motor speeds were too powerful, is going too fast. Well, instead of going through and changing every single line of code, I can just go up to speed, and instead of making it 75, I can say, okay, now I'm going to change it to 60 and see if that helps, right? So I can make one change here in this line where it says speed equals 75. I could change it to some other value, and it'll change it everywhere else the word speed is written. That's what makes the code easier, so I don't have to go line by line and keep adjusting things. I can make one statement in the beginning, use that integer throughout the code, and then when I change that integer, it changes it everywhere, right? So that's a quick way to make wholesale changes throughout the code. Now the second one is using the integer as an equation. So I set this up, and the first thing I say is, okay, I have this integer, I'm going to call it power, I'm going to set it equal to 0. So I've done two things, right? I first told the computer, hey, there's an integer, it's not going to use a lot of memory, it's going to be all whole numbers every time, so don't resort a lot of memory to it. And when we start out, it's going to be equal to 0. And then I've made this loop, right? So I've made this 1 equals 1 loop so that everything between this bracket and this bracket goes forever, right? We've done that before in class. And then I've asked a question. While the sensor value, the sonar sensor, is less than 100 or equals 1. So that means that everything that it sees is at least 100 centimeters away, or it doesn't see anything, right? So I have this while statement based on sonar values, and then I have this loop, right? So while this is true, while nothing's near it, it's going to keep doing everything between these two brackets. So let's see what that means. Well, power, which is my integer, is going to equal power plus 20. So initially it has a power of 0. The first time I put it in, we're going to add 20 to it. Then it's going to set it up. Well, the right motor is going to stay at 60. Right motor is never going to change, but the left motor is going to be whatever power is. So for the first time through this loop, it's going to be 20, which means the right motor is going to be more powerful than the left motor. So it's going to turn left. And it's going to do that for a second. Then it's going to go back through this loop and say, okay, well now power is power plus 20. So it was 20 plus another 20. It's going to be 40. So for the next second, this is going to be 60 because it doesn't change. Left motor is going to be 40, which means it's still going to turn to the left, but kind of very slightly to the left because the right motor is winning, but not by much. It's going to do that for a second. And then the next time it's going to be 40 plus 20 is going to be 60. So the right motor is going to be 60, left motor is going to be 60. It should go straight for a second. And then it's going to be 60 plus 20, it's going to be 80. Now the left motor is going to start winning, so it's going to start to turn to the right a little bit. Then it's going to go through it again, it's going to go through it again. As long as the sensor doesn't see anything, right, the left motor is going to get more and more and more powerful, which is going to cause it to take a faster and faster and faster right turn. So I've used this integer just to change the power of the left motor. So let's see. I have used virtual worlds. I have downloaded it. I've downloaded, this is the very last one, just to say it. This is in utility, and it gives you this blank table that has nothing on it except some marks on the ground, so you can kind of keep track of what's going on. This utility is very good just for testing things, right? If you don't want to do a specific mission, but you just want to try something out, this table is really good for that. So, just what I said, I expect it to take a right turn a lot, and then less, and then look like it's going straight, and then it starts to take a left turn, make it a faster and faster turn, and becoming a more severe turn. Now, it's never going to, at some point, it's going to cut off because we know the maximum power. The maximum power is 127. So once it gets to 127, the code's going to keep adding 20s to it, but it's not going to get any more powerful because that's the highest value it can get to. All right, so enough talking. Let's run this. Let's see what we have. There we go. Almost straight. Now it's starting, the left starting to win. Now it's starting to win anymore. And you can even see kind of how it jerks every second. And now it's just maxed out, right? The left motor's 127, the other one's 60. So it's just going to keep doing this the entire time. So there is an example of using an integer and having the value for that integer constantly changing. I'll back it up and I'll show it one more time, but you could always rewind this now and show it again. But there is my code. There is my integer that's going to increase by 20, which means the left motor power is going to increase by 20 every second. And then let's back it up and let's run it again. And you can kind of even see when it kind of jumps every second. And then again, we are maxed out. Okay, so there is our statements on integers. You're going to be using integers in virtual worlds for the two acceleration or simulated acceleration exercises. But we've talked about it some here. You see it in this video. And if you have questions, certainly let me know. But I think this is a very good start for what you need to do.